Our next video, we're going to talk about your VRMS and how this plays into your role and how this plays into power. VRMS is a very, very important concept, and we have to understand AC power and AC circuits and how they work. And the terms are very, very confusing. So really, the trick to this is the terminology of how things work. Okay, so here is your sinusoid. This is a cosine wave. Okay. It's really not that important. What's important is that's your V, okay? Now, you have to understand something. This is a standard wave across the world, right? Every single AC circuit, every single AC voltage has this equation, okay? Now, I don't want you to master this equation. I want you to understand this equation and be able to replicate it. I don't want you to calculate anything really difficult out of this, okay? So first understand that what these values mean. The first thing I want you to understand and label is, what is this? VM is max voltage, okay? And max voltage is called your amplitude, okay? And I'm going to go ahead and just label this graph here real quick. It's called amplitude. On this graph, where is my max voltage? My max voltage is here. That's my VM. And not here to here, but only from here. And I will draw this out. Okay? Which is V peak. Okay? Now, there's something called, so here, max voltage amplitude is also called V peak. So VM is equal to V peak. Okay? Now, there's a concept called peak to peak. What is peak to peak? Peak to peak is here. Okay, if you want to call peak to peak, then it's simply this. Okay, V peak to peak is 2 times V peak. Okay, so this is V peak to peak here. I'm going to go ahead and label that peak to peak. Okay, so V peak is V peak to peak divided by 2. Okay, V max and VP are the same. Okay, so know these things. Okay. Second thing you have to know is this is called the phase. Simply the phase, not time. Okay? The third thing you need to know is if I call this T, like see you have omega. This is called omega. But it's a small omega. Where your resistor is a big omega, so R is a big omega, right? In field theory, it's small omega. And omega is simply angular frequency. And what you need to know about angular frequency is this is 2 pi f. That's it. Anytime you add a 2 pi, it gives an angle. The 2 pi of a circle makes this something an angular rotation. That's all. This f has 2 values only. The first value of f is 50. The second value of f is 60. In the US, Canada, and usually in industrial parts of the world, we use 60 hertz. Okay, this is hertz, 60 hertz. Other parts of developing world uses 50 hertz. If you go to, let's say, parts of developing areas, let's say, parts of Africa, parts of Asia, you'll see the Middle East, all over the place that are developing, it's 50 hertz. Okay, I'm not sure exactly why. 60 hertz is better because you divide into 360 circle better, but that's just how it is, right? Okay, so in the US, our peak to peak, or I'm sorry, let's cover the hertz first, okay? Then we call RMS. Okay, now there are a few things you have to know, okay? So we covered frequency, we covered peak to peak, we covered V peak, right? We covered the equation, we covered all this, okay? You would probably have to, honestly, would make your own graph on the homework or something similar to this, okay? Number 2, let's define the following terms. V peak, which we already know. V RMS, V DC, and V effective. Okay? These are the 4 things you really need to know. So we know what V peak is, right? What is V RMS? V RMS is basically what comes out of a plug. Okay? So when you're measuring, let's say, this voltage coming into a plug, you're coming in outside, right? And you're here, okay? And you see all this stuff coming in, okay? And this is V peak here, and this is your V peak, you know, cosine omega t plus phi, right? And this goes into a plug like such, and you're going to plug something into a wall, okay? Well, it's not really reading that. It's reading something called VRMS, okay? What is VRMS? VRMS is the measurable voltage that you can read from a voltmeter. So when it says 110 volts, it doesn't mean our peak to peak is 110. It means our VRMS is 110. And our VRMS is determined as 0.707 V peak. So our RMS is a value that is measurable. You really cannot measure peak to peak without sophisticated equipment. And if it does, it still measures RMS and calculates the peak anyway. So it really doesn't matter. Okay? Our VDC, okay, when we switch this AC to a DC, right? Our equivalent VDC is basically VRMS. This means approximately, but pretty much VRMS. Okay? When we say our effective value, what is our effective value? That means amplitude is the same, right? We are referring to VRMS. It's the same thing. Your effective voltage is your measured voltage, which is equivalent to your VDC if you go AC to DC, which is equivalent to your RMS. This is the same terminology. Okay? There's no difference. However, if you were to measure VP, you would basically try to measure V peak here with an oscillation. You would use what you call an oscilloscope. Okay? If you were to measure this, you basically use a voltmeter. So when you put a voltmeter into a plug and you measured 110 volts, that's your RMS value. 120 volts, RMS value. You want to calculate your peak to peak. And you'll generally get 60 frequency, as a normal. Right? So how does this all tie in? How does this all tie in to something? Right? Well, it ties in because, okay, how does RMS, so the question is, how does my RMS relate to power? How does it do that? Okay, it's very simple. When we measure power, our P average or P real is simply our VRMS times my IRMS times my power factor, which we covered before, right? IRMS is what? Obviously, I peak to peak times 0.707. VRMS, we know that it's V peak times 0.707, right? And our power factor is simply the cosine of the angle. Most of the time in the machines, your power factor is given. Okay? When you read these machines, you'll see the power factor is given and your RMS value. So if you look at any machine, for any sense and purposes. Okay, if you look at the label, if you look at the diagrams, it'll say RMS. Those are your RMS values. It'll never give you a peak-to-peak value. It may, but it's very unlikely. You'll see the RMS value, you see the power factor. Immediately calculate your power. Once you know your power factor, it sets the tone for your total power, right? And we will go over how to get total power in another video. That's right. Now, you can have the same value here. Like here, we can say P is also equal to VM IM over 2 times your power factor, right? We can do that. Unfortunately, when you have a case like that, VM IM over 2 times your power factor, that is really not how it works, because that is actually your max amplitude, and that is not how really we want to do it. Really, just we want to stick with this. Now, if you are given this, you go ahead and use that equation, but really you need to know this. Okay, you can stop the video and then review your homework. Your homework is based on this video. All right, good luck, guys.